So yesterday we talked about I, these imaginary terms, these complex terms. A complex term is A plus BI. Let me go back to this here. So any term in the form of A plus BI is a complex term, where A is the real number and BI is the imaginary. I don't know why I about wrote complex. Is the imaginary part. And the whole thing comprises a complex number. Now, for some reason, the name of the theorem is slipping my mind, but there is a theorem that states that any number can be written as a complex number. Any number can be written as a complex number. It's not. That's a different theorem. Because we don't have it in here. I'll look it up later. Because I think it's probably the complex number theorem or it's a different theorem. But any number can be written as a complex number. So in that train of thought, what do you think is a number that cannot be written as a complex? 0. 0 here, it seems like we can't write this as a complex number. However, two of us in here know how to do it. So how would I change this into a complex number? Remember? Yeah, because how can I write this as a complex number in the form of A plus BI? Because we did this in pre-cal. It's very simple. We do. Because for any number, any real number, I can always add plus 0i, yes? Now it's a complex number because it came in the form of A plus BI. And we can do that with any number. Any number can be written this way. So that's kind of a side note. We won't deal too much with that. All right, guys, focus up here. Now, the first thing we're going to talk about is this here. If a polynomial px with real coefficients has the root a plus bi, then a minus bi is a root of the polynomial function also. So it's saying if a plus bi is a solution, then a minus bi is also. Well, it also means if a minus bi is a solution, then a plus bi is one also. These are conjugates. The conjugate. Because the conjugate of a plus bi is a minus bi. We're changing the sign in front of the imaginary term. Can you all see this here? Yes? Now, this will make more sense when we look at the first one. Because this is going to come in two parts. We're going to find the conjugate, and then I'm going to multiply them together. It doesn't ask for that in the assignment, but I'm going to show you what happens. So looking at this here, 7 minus I, what would the conjugate be? 7. Because if a minus bi is a solution, then a plus bi is also. So we're almost changing the sign with the I term. And we'll look at the multiplication in a second, but I'm going to look at the other one. Negative 5 minus 5i, this would be what? And the term with I is the only one that has a sign change. The term with I is the only one that's going to change the sign. Any questions on this here? Any question on anything we've done so far? Now, I'm going to show you the reason why we care about these conjugates. I don't think you quite have the space for this to be written in on your page because you don't have a lot of space there. But I'm going to multiply these out. Now, 7 times 7 is 49. 7 times positive I is plus 7i. Are we good with this here so far? Negative I times 7 is negative 7i, yes? And negative I times I is negative I squared, yes? Well, what happens to our two like terms in the middle? They combine to become what? So we have 7i minus 7i. These cancel out. They become 0, yes? So I have 49. What did we say I squared was yesterday? -1. I squared is going to be one of the two with I that you really need to know. I squared is -1, and I is the square root of -1. Because those two are the most common, and they're going to show up the most. So really what we're saying here is that I have 49 minus -1, yes? Well, negative and negative make a, which gives me, how many imaginary terms do I have? None. They all canceled out, yes? That's why these conjugates are important. Because when we multiply a complex number by its conjugate, the imaginary terms will cancel out completely. Whenever we multiply a complex number by its conjugate, the complex numbers will simplify out completely. That's why they're important. That's why these are helpful. So looking at this one here, -2 plus 4i, its conjugate would be? -2 minus 4i. Because again, what are we changing? We're changing the sign in front of the imaginary term, the imaginary part. How about number 4? 3 plus 6i. Since 6i was negative, it becomes positive. Any questions on this here? And again, if we multiply these together, they would end up simplifying out. The I terms would simplify out. And I believe this should give you 45. And this should give you 20. Because again, you can type these in the calculator, like we saw yesterday with multiplication. Because if I wanted to, for this one here in the calculator, you could type in -2 minus 4i times -2 plus 4i. And that would simplify all the way down. And it should give you 20. Yes? Any questions on finding these conjugates? We good with these here? Yes? Let's see here, because I think these are the last two. Okay, those are the last two. Now, I want to undo that. Needs to be to the right. What is the complex conjugate of 7i? What is the complex conjugate of 7i? Because what have we been doing? We've been changing the sign in front of the term with I. Because what we could also, we could look at this as 0 plus 7i, yes? Because we can add 0 to anything, it doesn't change its value. Which is the same as this here. So those are those two there. Find the complex conjugate of 64. Because what are we doing? We're changing the sign in front of the term with, does 64 have a term with I? No. So really what we're saying is that I have plus 0i. I change it to become, well, 64 plus 0i is just 64, yes? 64 minus 0i is just 64, yes? So if it's a whole number, it's not going to change. Because we're only changing the sign in front of the term with I. Questions on this here? Now we're going to look at division. Now, the reason we have to simplify this is because we do not want an I term in the denominator. I'm going to rewrite this so it looks a little bit bigger. We do not want to have an I term in the bottom of the fraction. That's what our main goal is. Do I have a method for some way to get rid of all the I terms in the bottom, or in this 1 minus 2i? Because of our conjugates, yes? Because if I multiplied 1 minus 2i with what? 1 plus 2i, the I terms would simplify, yes? So what we'll do here is we're going to multiply this by what I call a fancy 1. Because we said if I multiply the denominator by 1 plus 2i, the I terms will simplify, yes? What do I need on top? Because what is 1 plus 2i divided by 1 plus 2i? It's just 1. Anything divided by itself is 1, yes? If I multiply a number by 1, does it change its value? So here, what am I really doing? I'm multiplying that fraction by what? 1, yes? It doesn't change its value. That's why we can do this. So when we multiply straight across. So our 4 plus 3i is going to be multiplied by 1 plus 2i. And 1 minus 2i is going to be multiplied by 1 plus 2i. So we're going to be multiplying these together. We can start with the numerator. 4 times 1 is 4 times 2i. Well, 4 times 2 is plus 8i. 3i times 1 is going to be plus. And 3i times 2i is plus to the second. So that's the numerator done, yes? We're good with that step, multiplying through. Let's look at the denominator. 1 times 1 gives us 1 times 2i. So we have positive 2i. Negative 2i times 1 would be minus. And negative 2i times positive 2i is going to be minus squared. So the 2 and 2, yes, these will cancel, yes? So we have 1 minus 4. Can I have I to any other power? Or have it to a power? No. I cannot be to we cannot have I to any power greater than 1. So what is I squared? Do I have any I terms left in the denominator? No, so that's what we wanted. Now in the numerator, well, I have 4 and 6i squared. They're going to eventually combine, yes? Because I squared is a negative 1. We'll do that in a minute. So I'm going to leave 4 alone for now. But 8i and 3i will combine to give me what? 11i, yes? Well, I squared is negative 1, yes? Well, here we have 4 minus 6 plus 11i. Are you guys okay with me doing that? Because positive 6 times negative 1 would be negative 6, and I just moved it over. Y'all see what I did there? Yes? Now in the denominator, negative 4 times negative 1 would be plus 4. Any questions before we hit the last step? 4 minus 6 is plus 11i over 5. Now this here we can split up into 2 fractions. And I'll take it in either one of these here because we can rewrite fractions by splitting them apart. Yes? We'll take it in either one of these 2 forms. And that's our answer. That's why we have these conjugates, so that we can simplify the denominator. We can get the imaginary terms out of the denominator of the fraction. Any questions on this here? I'm feeling some of you are looking at this. Well, we were able to plug everything into the graphing calculator yesterday. Can't we do this here? Try this. Plug it in. Go. Alpha, y equals enter. Alpha, y equals enter. And the I button, if you don't remember, you do second, and then the decimal point down at the very bottom is that. See, that had an error. I'm guessing just plugging it in didn't work. Has anybody got an answer that matches up to what we have up on the board? Error. Well, you don't have to type, I mean, if you just type 4 plus 3i over 1 minus 2i, you don't have to type the whole multiplication in. You got it? Yeah. That one's more advanced. It's a newer one. It'll do this.
Good job.
Okay. And unfortunately, I have 3 of them. 2 of them are being used by the pre-cal class. Now, it's not impossible to actually type these in. You just have to type them in correctly. All right? You're all ready to follow the keystrokes for this here. Parentheses. 1 minus 4i. Close parentheses. Second decimal will give you I. Once you get that typed in, hit enter. So it gives you an ugly number, yes? Yeah. Okay, we're not done yet. Hit math. There should be a button that says math. Y'all see that? And in the first one, it has a little arrow, FRAC. Hit enter. Hit enter. What do y'all get? That's it.
The first one that's there, just click enter after you click.
Yep. Mm-hmm. So it says FRAC. This is not the full word. Do you know what the full word is? Fraction. What you're telling the calculator is whatever number was before it, that arrow is before the arrow. Take whatever that is and turn it into a fraction. So when you hit this, what the calculator should have said is A and S, and then the arrow fraction. A and S stands for answer. So whatever the previous number that was generated, the one that you just hit enter before, it's going to turn that number into a fraction. So these calculators will do it. We just cannot do it as an actual fraction. It won't work. So we have to tell it to divide the two things and then turn it back into a fraction. Questions on this here? So if you get stuck without a calculator, we have to do, let's see here, I'm moving that. We have to do our complex conjugates, which for here would be multiplying it by negative 4i, and using these complex conjugates to find it. However, the graphing calculator will do it for us. So this one here is a little bit nicer, because we can multiply negative 4i times 2 is negative 8i. Negative 4i times negative 5i is going to be negative 20i squared. Negative 4 times positive 4 is going to be negative 16i squared. Right? Which would give us 20 minus 8i over 16. Now we can split it up like the calculator did and do 20 over 16 minus 8 over 16i. Because I think if some of you already typed it in, your answer doesn't look like this. What's 8 over 16? And we have 5 over. That looks like it? Because it's going to simplify it. It's going to put it in simplest terms. We're able to figure that one out. So, math, fraction, so here, so math, fraction. Let's see here. So for this one here, let's do the first one. 4 plus 3i divided by 1 minus 2i. We get this here. Math, fraction. And it works with almost any fractions. It will convert it over. So any questions on these here? And it works with any of them. Doesn't matter what it is. It will find it. And that's it. That's all we have.